The trapezium rule. What happens when a mathematical function cannot be integrated? For example, integrate e power x squared dx, or integrate sec 1 plus x cubed dx. In these cases, a numerical method can be used to find an approximate value for the integral, as the definite integral of fx from a until b is the area between y equals fx, the x-axis, and the line x equals a and x equals b. Therefore, even if the integral of any function from any value to any value cannot be found, approximate value for it still can be found by evaluating the appropriate area using another method. That is the trapezium rule. The trapezium rule. This method divides the area A under the curve. Okay, this curve is y equals fx into n vertical strips. The width of each strip is h. Okay, so the area under the curve is approximately equal to sum of all areas of n trapezia. So note, this symbol is approximately equal to. Okay, so what we have now is area under a curve. That is y equals to fx. This area is denoted by a. It is from a until b. Okay, and this area under the curve, we want to divide this into n trapezia or n trapezium. Okay, and each trapezium has same width, that is h. This is what it means just now. So you can see that a, this is a, okay, from x naught equals a until xn equals b. So this area is a under the curve y equals to fx. So you can see that we divide this area into n trapezium. Okay, so we have y1, y naught, y1, y2, y3 until yn. Okay, until yn. So we can let y naught, y1, y2 dot until yn minus 1, and last 3 is yn, be the values of the function fx. This corresponds to the n plus 1 ordinates respectively. Okay, using area of the trapezium, okay, equals half times width times sum of the parallel sides. Okay, for example, we have this trapezium. This is the width of each of this trapezium. Okay, they have same h. Okay, and this is the parallel side. Okay, y1, the sum of the parallel side, y1 plus y2. Okay, okay, this is a under the curve. The trapezoidal or the trapezium rule estimates the area under the curve as integral of fx from a until b dx is approximately equal to sum of the areas of the trapezium. This is the area of the first trapezium, the second trapezium, the third and until the end trapezium. So this is h, the width, this is the sum of the parallel sides. then over 2. Okay, and we'll have here, you can see h, so it can be factorized. And for this x naught over 2, we have 1 here, so times half y naught, y naught. And this will be the y1 over 2 plus y1 over 2. So it will become y1. As for the y2 over 2 plus y2 over 2 here, it become y2. And then until the last one is yn over 2. Okay, so we have yn over 2. The term which consists of half here, that is half y naught and also half yn. So it will become, this will be half. Okay, so y naught plus yn. And all those values between this y naught and also yn, you can see it happened. There is no half. Okay, and then we should times 2 here, because to make it 1, 1, and so on. Okay, so because we factorize this h over 2. So it is like this, where h is the value, okay, the upper value here, we minus the lower value, a over n, okay, over n. What is n? N is the number of the strips or subinterval, and yr is equal to fxr. Example 1. Evaluate integral of ln x dx from 1 until 5 using 4 strips by the trapezium rule. Note, we can calculate the values of y0, y0, y1, y2, y3, and y4 from the table using scientific calculator. Solution. The integration interval b minus 1, that is 5 minus 1, we have 4 units. So h is b minus a over n. So we have here 4 over 4 is 1. The value of x at which y is calculated are 1, 2, 3, 4, 5. Okay, and then we shall input into this table. X here is representing the value 1, 2, 3, 4, 5. Okay, in the first column. In the second column is for y equals ln 1. Y equals ln x. So we have here y naught is when we have ln 1. Okay. So in the third column we have the first and also the last ordinate. So now we calculate ln 1. Y naught is ln 1. So we have 0. And the last ordinate is x equals 5. This is y4. Okay. So we have ln 5 is 1.6094. And then this column, we go to add up together, we have 1.6094. As for the remaining ordinates, we will have here ln 2. Okay, when x equals 2, y is ln 2, and we have 0.6931. And this one is ln 3, 1.0986, and ln 4, 1.3863. Then after this, we also have total. Okay, for the remaining ordinates, you add up together, you have 3.1780. And then after this, we will use this value, okay, in order to find ln, integral of ln x from 1 until 5. This is approximately equal to h over 2. Okay, h just now, we already have the value is 1, so 1 over 2. And then times y0 plus y4. Okay, that is the value for the first and the last ordinate. 1.6094 plus 2 times y1 until y3. And then we input value. So we have like this. And lastly, we calculate the value. This should be 3.98, okay, 28. Example 2. Use the trapezium rule with 5 ordinates to evaluate the integral of e power x squared from 0 until 0.8 dx. Correct your answer to 3 decimal places. Solution. Notation. Working must have 4 or more decimal places. 5 ordinates is equivalent to 4 strips. So therefore, h should be 0.8. Okay, that is the bigger value minus 0, the lower value, over n. So we have 0.2. The values of x at which y is calculated are 0, because it started from 0, and then plus 0.2 is 0.2, and then plus 0.2 we have 0.4, plus 0.2 we have 0.6, and plus 0.2 we have 0.8. And the last one must equal the bigger number. Okay. And we have to input the values of x into the table. And the first column, we shall have all this value for x. 0, 0.2, 0.4, 0.6, 0.8. In the second one, we shall input the value for y. Okay, that is y naught. That is when we have x equals 0, and we shall have the value for the y. Okay, this is the first and so the last ordinate. Okay, now we shall put the values of y naught. That is when e power 0. Okay, we use this function, so substitute x as 0, so e power 0 is 1. And we go to the last one, this is y equals e power 0.8 square. Okay, use your calculator, then we have 1.8965. And for the remaining ordinates, okay, we shall calculate y equals to e power 0.2 square. Okay, x is 0.2, so e power 0.2 square, then we shall have here 1.0408. And for y2, its value is whenever e is substituted by 0.4, I mean. So e power 0.4 square, then we have here 1.1735. And so for the, when x is 0.6, we have y3. This is 1.4333. Then after this, we have to add up this together, and it will become 3.6476. And this column is 2.8965 when 1 plus this value. Okay, after having done this, then we'll input into the formula. So what we want to find out is the integral of e power x squared from 0 until 0.8. This is approximately equal to h over 2, and then times y naught plus y4 plus 2 times the remaining ordinates. So we have h just now as 0.2, and then we have put it into the formula, and then we have here y naught plus y4 is this value, 28965 plus 2 times this value. Okay, and use the calculator, then we have 1.0192. Okay, and we want this to be 3 decimal places. Okay, this one is 4 decimal places. Make it 3 decimal places, you have 1.019. Example 3. Approximate the integral of 1 plus x dx from 3 until 5 by using trapezoidal rule with 4 strips or 4 sub-intervals. Give your answer correct to 4 decimal places. Okay, notation. Working must have 4 or more decimal places. Solution. We go to find h. Okay, so 5, the value 5 minus 3 over 4 for the 4 strips. We have 0.5. So therefore, x should be, the values of x are 3, 3.5, 4, 4.5, and 5. And then tabulating the results as follows help the final calculation. So we have this table. Okay, in the first column we're going to have all the values of x. Okay, x naught is 3, x1 is 3.5, next is 4, next is 4.5, and the last one is x4 equals 5. Okay, while for this column of y, we have the first and also the last ordinate. Y naught is third 1 plus x naught. This is 3, 1 plus 3. So third 4 is 2. Okay, and we have y4 is 1 plus x4. x4 is 5. 1 plus 5 is 6. 6 is 2.44949. And then we add up this value and it becomes 4.44949. And then we shall go to the remaining ordinates. y1 is 1 plus x1 or 1 plus 3.5 third. So we have third 4.5. We have 2.12132. Okay. Next is y2. So substituted 4 here. So third 5. 2.23607. And y3 is third 5.5. We have 2.34521. And then, as you can see that the calculation all have 5 decimal places, because our last answer should be 4 decimal places. Okay, after this we will add up all these values together. We have 6.7026, and then use the trapezoidal rule, and then we can find now the approximate value for the integral of third 1 plus x from 3 to 5. Okay, so if this is equally, this is approximately equal to h over 2. Okay, times y naught plus y4 plus 2 times the remaining ordinates. And then we have h just now is 0.5. Okay, put it here, 0.5 over 2. And then times 4.44949 plus 2 times 6.70260. Then altogether we have 4.4637. This is 4 decimal places.